First lesson of a new unit on all of the properties that make triangles triangles. Now you know a triangle is a three-sided polygon. It has three sides, but it also has three angles. Okay, it's a polygon with three sides and three angles. And remember, a polygon is just a closed shape. I apologize for the video being dark. I can't figure out what's going on. But hopefully you can see it. But we're going to talk about ways that we can name these triangles. And we can name them by their angles. Only by their angles. And so if we have an acute triangle, draw a picture here. An acute triangle just has three acute angles. So this triangle right there is an acute triangle. It doesn't, we're not talking about the sides. It doesn't have anything to do with the sides. Here we're just saying it's got three acute angles, so it's an acute triangle. Okay, whereas over here, you can make a triangle like this, where it has an obtuse angle being bigger than 90 degrees, and so maybe this is like that. And so here we have this one obtuse angle, and so we call it an obtuse triangle. It can't have two obtuse angles because all of the angles in a triangle have to add up to 180, and we'll talk about that a little bit more. So if we can only have one obtuse angle. Likewise, we can only have one right angle because the right angle is 90 degrees, and two of those will be 180. And we have to have three angles equaling 180. And so in a right triangle we have one right angle. One right angle, and then obviously the other two are going to be acute. And the obtuse one, the other two are going to be acute. Now coming down, we can also name triangles by their sides. Okay, so we're not talking about the angles, just talking about the sides right here. And a scalene triangle, and a lot of this you maybe have heard before. A scalene triangle has three sides that are different lengths. Okay, and again, if you're looking at this, you can say, well, it's acute too, and it is. And so we will call this an acute scalene. Just looking because all of these angles are less than 90. But just focusing on the sides right here, we call it scalene. Isosceles means that two of the sides are the same. And those tick marks, remember, mean those two sides are the same. So we maybe say this is 10 inches long, and that's 10 inches long, and this is 6 or something. Okay, isosceles has two congruent sides, whereas scalene had no congruent sides. And then lastly, equilateral, equa meaning equal and lateral meaning side. This literally means equal sides. All three sides are exactly the same. And maybe 4 centimeters, 4 centimeters, 4 centimeters. All congruent sides. All three of them are congruent. Okay? And you'll see, I mean, the way that we drew these, all of these are acute. But we could have come here, I mean, you can have like an obtuse isosceles, if we make both of these the same size. And this be 100, and that'd be 40 and 40 or something like that. And so here you'll see that this would be an isosceles, isosceles obtuse triangle. So we have two different ways to name it, by its sides and by its angles. And we'll practice those a little more. But moving on, we talked about all the angles add up in a triangle. They always add up to 180, and that's an extremely important concept. So we're going to prove it. We're going to prove that this is always true. And so on your paper, if you will just draw a triangle, any triangle, doesn't matter, Does not matter how you draw that. You can look like mine, doesn't have to look like mine. I got this extra piece, I shouldn't. Any triangle. Now we're going to draw a line parallel to the bottom line on your triangle. If your triangle looks like this, then your line is going to be parallel to that bottom. However your triangle looks, draw a line parallel to the bottom. Alright, because that line exists, we can do that. Now let's just number some of these angles. Let's call this angle right here angle 1, this one angle 2, that one angle 3, this one angle 4, and this one angle 5. Alright, now what we're going to try to do is prove that in this triangle, and yours should hopefully looks different than mine, and in your triangle, and any triangle we could possibly draw, angle 2, 4, and 5 are always going to add up to 180. Now let's prove that. Now some of you, your mind is already turning, and you're saying, well, we made this parallel to this bottom part for a reason. And you should know by now, you should have enough practice, and when you see parallel lines, you should think alternate interior, same side interior, corresponding. And you'll see these two cross over the line. We say crossover angles, Allen Iverson, alternate interior, AI angles. Okay, so we know that angle 1 is going to be the same as angle 4 because they're alternate interior. And then we see over here the same thing going on, 3 and 5 crossover. They're also alternate interior, so we know they're the same. And then there's one other piece of information that we can see here, that these three come together to make that line. And we know that angles that make up a line are 180 degrees. So angle 1 plus angle 2 plus angle 3 have to equal 180. And we'll just say because they make a line. Now if you're thinking, okay, well if angle 1, 2, and 3 equal 180, well we just said 1 is the same as 4, and 3 is the same as 5, right? They're equal. 1 and 4 are the same exact thing, so instead of 1 I'm just putting a 4. 3 and 5 are the same, so instead of 3 I'm just putting 5. I'm just substituting. And then all of a sudden 4, 2, and 5 equal 180. We just proved it, that 4, 2, and 5, we're not even using numbers. There were some of you saying, this is weird, we're not even using numbers. And this is not something that you're going to have to do for the rest of this unit. We just did it because it's fun. But to see no matter how you draw the triangle, on your paper, it doesn't matter, that they're always going to add up to 180. And that's a pretty cool proof, I think. So here we go. They all equal 180. Okay? All right, so moving on, we just proved it, that they all add up to 180. And so you'll see problems like this where you're given two angles and you need to find a third. And so you just need, oh, okay, well, they have to add up to 180. So using your head or your calculator, we'll add these two together and get 94, and then just subtract 94 from 180, because all three of those have to add up to 180, and we will get 86. Okay? They also ask us to classify. That means name. Tell me the type. Well, all of these three are less than 90 degrees, and so it's a cube. But what about the sides? We don't know anything about the sides, so we can't name anything about the sides. But I'll give you a hint of something that we're going to learn about later, and that's, you see how all three of these are different? Well, if the angles are different, then the sides have to be different. I know it doesn't quite look like that, but keep in mind, a lot of these I drew on paint, and so they're not exactly drawn to scale. But if you think about this angle 86 degrees, it's going to be opened up wider than this angle of 43 degrees. And so if it's opened up wider, that means this side is going to be a little bigger. So if all the angles are different, all the sides are also different. So this is an acute scalene triangle. They didn't tell us anything about the sides, and we're jumping a little bit, but we'll just write that down. But if that doesn't make sense, we'll get there eventually. Just make sure that you can name it by the angles. All right, coming over here, we want to figure out what this is. And you'll get really good at right triangles. We're going to do a whole unit on them. Because if all three of these add up to 180, 180 minus 90 means these two have to add up to 90. And so this is going to have to be 70. Okay? Or we could have just added these two together and subtracted from 180, either way. Okay, and so now we have a right triangle. And all of the angles are different. That means all the sides are going to be different. All right, so it's a right scalene triangle. Okay, coming over here, and you may also notice, okay, yeah, that's an obtuse angle. Sure. Okay, add these two together, we get 159, and let's subtract that from 180, and we get 21. Okay, and maybe you're picking up on the pattern. If you just want to call this an obtuse triangle and call it a day, that's fine. But for those of you who are curious, you're saying, well, when all of them were different, we had a scalene triangle. Now we have two of them being the same. And this will hopefully make a little bit more sense later on, but then we know these two things have to be the same, which means we're going to have an isosceles triangle. But at the very least, just make sure that you can call it obtuse. All right, number 4. It says find the missing angles. We're not given any information about the angles. Here we're just saying all three of these are the same. And so you should notice right away, okay, this is an equilateral. The cool thing about equilateral is that every equilateral triangle is the same as every other equilateral triangle, or they're all similar. In that these three angles, we don't know them, but they all have to add up to 180. And if all the sides are the same, then all the angles are the same, which means that this has to be 60, this has to be 60, and that has to be 60, because 180 divided by 3 is 60. And so this is an equilateral acute triangle. And we'll talk a lot more about equilateral and isosceles triangles a few days from now. Coming over here, we got this weird looking thing where we're missing two angles, but here's where we can use some old concepts and see that, oh yeah, these are vertical angles. And that's something by now you should just see and automatically know. Vertical angles right there. So if that's 28, that's 28. Now I can add these together, it'd be 90, 103, and I'll just subtract that from 180 and get 77. Okay, and so this is acute. All the angles are different, which means all the sides are different, so it's scalene. Lastly, it asks us to draw an obtuse equilateral triangle. And you may spend a lot of time saying, how can I make an obtuse angle and get all the sides to be the exact same length? And it's just not going to happen. If you go back to this idea, if all the sides are the same, all the angles are the same. And if all the angles are the same, we can't have an obtuse angle. And so this is not possible. And during class, we will try to draw several of these, and sometimes they're just not possible. We just can't do it. Okay, that's it for today. Pretty short lesson. The big idea is just naming triangles by their angles and by their sides, and that all the angles in a triangle always add up to 180. Those are two ideas. If you have any questions, please write them down. Have a good day.